Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X Causing Multicolored Sunsets on Earth. Now, colorful sunsets have become a daily event on Earth. I started investigating what was going on in the solar system in 2016 because of the strange colors I saw in the sky close to sunset. At the time, I mainly saw clouds illuminated with magenta light, but since then I have observed clouds illuminated by other colors such as red, orange, pink, peach, bright yellow, and blue. Nowadays, several different colors are often seen in close proximity to each other, yet the color arrangement can change from day to day. So how are these produced? The sun is supposed to emit white light. So one thing should be obvious from the very beginning, and that is that the sun cannot be the source of these colors observed at sunset. So the different colors implies that different sources of light are illuminating the earth. And here you see two colorful sunsets. In this one we see clouds that are illuminated in pink light, yellow light, and purple light. And in this one we see yellow, orange, and pink. And this is a photograph which I took, and you can see some clouds illuminated by pink light or magenta light. Now, a few reddish clouds at sunset close to the horizon can be explained in terms of the red wavelength in sunlight being more refracted by the atmosphere than the other wavelengths. But how can clouds almost all the way to the opposite side of the sky, in which the sun is setting, that is on the eastern side of the sky, be red? Once the sun is no longer visible, the clouds in the eastern sky should be gray only, and the sky should be gray as well, but we do not see that. So I illustrate here what we should be able to see, and that is this is light coming from the sun. Now, for an observer at sunset, where the sun has already set below the horizon, say the observer is here, the observer may see some red clouds on what we see here as the left-hand side of the observer, but it will be in front of him as he looks at the sunset. And this would be because a light ray coming in through the atmosphere may be refracted so that some of that red light may reach a cloud here. But this cloud has to be in front of the observer as he looks at the sunset. For that light to reach clouds on the other side of the observer, that is on the eastern side of the sky for the observer, this would not, it simply not work. The light will not reach there. So this is what's actually occurring. I often see clouds that are red and often other colors. They may be peach, they may be pink, they may be blue. All kinds of colors are often seen illuminating the whole atmosphere all the way around from one horizon to the other. So this means that it cannot be sunlight, which is the source of this illumination. It can only be explained if an object emitting that color, in this case the red light, if it is the red light, close to the earth. So here we see this object which is close to the earth, but it is on the western side, so that these two clouds, both of them, can be illuminated by light coming from this object. This object cannot be here between the sun and the earth. It has to be more on the western side for this to be possible. And this object cannot be where the sun is, because just like sunlight would not be able to reach that light, a light from this object would not be able to reach that cloud either. So it would take a red object in this position to illuminate clouds at the time of sunset for this observer. Now, if the light illuminating the clouds is pink, then even if the illuminated clouds are on the left side of the observer's position, it cannot be the sun illuminating them, because pink is a combination of blue and red, And blue light is refracted by a much smaller amount than red light, and it would not reach these clouds once the sun is no longer visible above the horizon. But why would the red or pink object producing these colors in the clouds at sunset not also illuminate them at other times? The light emission from these objects is most likely not intense enough to be noticeable when the simulators are brightly illuminating the atmosphere. This also shows that the sun cannot be the source of the red light. If the sun was the source of the red light, because the sun's light emission was now only in the red wavelength, then the whole planet would be bathed in red light all day. The sun simulators would not be able to stop the sun's red illumination from coming through. It is also simply not possible to block out the sun, as in order to do that you would need the shield to have at least the same diameter as the Earth. The shield would have to be a disk with a diameter of about 8,000 miles or 13,000 kilometers. This is simply too large to be possible. If the powers that be cannot block the illumination caused by several different light sources approaching the Earth, which are most likely much smaller than the sun, how would they block out the sun? And so this illustrates how large the shield would have to be. It would have to be 8,000 miles in diameter. And then where to place it, because it would have to remain stationary between the sun and the Earth. And the only possible position would be the L1 position. But then there may be some relative movement, which would require it to be even larger. Now, the fact that the colorful illuminating objects are close to the Earth also explains why sunsets may be different every day. Different objects would be in the sky close to the observer's position at sunset. The fact that these objects do not seem to illuminate the night sky suggests that they tend to remain on the sunward side of the Earth, and indicates that they come from the sun, interact with Earth for a while, and possibly return to the sun. It is the smaller of these objects that are likely to get to the Earth once ejected by the sun, because they just have less mass and will move further away from the sun. Now here's illustrated what we would expect if we had a pink and a blue object close to where this observer would see the sunset. So you would see both these colors at sunset. Obviously, an observer somewhere else on Earth, say an observer here, which will see the sunset a few hours later, may see something different because these objects may not be in that position anymore. But what we see here is that this object is able to illuminate only the high altitude clouds here, whilst this one is able to illuminate them both. So we're going to get a combination of blue and pink in the sky, which this observer will be able to see. So in conclusion, the different bright colors observed in the sky during sunset can be explained if they are stellar cores close to the Earth and on the sunward side of the Earth, but more to the western side of Earth at sunset. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.